Okay, light of an unknown wavelength emitted by a laser is directed through a pair of thin slits separated by 50 micrometers. We all know what that little u means? It's times 10 to the negative 6. The slits are 2 meters from a screen on which bright fringes are 2.5 centimeters apart. Calculate the wavelength of the laser light in nanometers. Okay, so like any physics problem, we write down what we know, we write down what we want to know. So what do we know? We know delta x. We know our fringe spacing is 2.5 centimeters. Okay, or that would be 0.025 meters. We know our fringe spacing. Okay, what else do we know? We know our distance between slits. Oh, what's that? Our distance between slits, d, is 50 micrometers, which is 50 times 10 to the negative 6 meters. Okay? If you can't remember this little weird u, what's actually called a mu is micro, times 10 to the negative 6. What else do we know? We know our length from the slits to the screen is 2 meters. And we just want our wavelength. So remember, from our formula, delta x is equal to wavelength L over d. So if we rearrange this a bit, we get d delta x on L will give us our wavelength. So, what is that? So we get d of 50 times 10 to the negative 6 multiplied by 0.025 divided by 2. Okay, and I get 6.25 times 10 to the negative 7 meters. Now the question is asking for it in nanometers. Okay, so you can see up here in nanometers. So nano is times 10 to the negative 9. So we'd need to multiply this number by 100 to get to that, which is equal to 625 times 10 to the negative 9. Or 625 times 10 to the negative 9 meters, or 625 nanometers. Is that a common sense answer?
Yeah.
Why or why not? Yeah, sorry, Adrian, what did you say? It absolutely is in the visible spectrum. Okay? Visible spectrum is basically from 380 to 780 nanometers. Okay? If you get hundreds of nanometers in any one of these answers, you've probably done it the right way. Okay, so 625 nanometers is definitely in our visible spectrum. All right.